In this final video tutorial on working with complex numbers, we are going to be finding the absolute value of a complex number. Now, general absolute value of a number is defined as its distance from zero on a number line. The same premise holds almost true for the absolute value of a complex number. What we're looking for, instead of its number's distance from the origin on a real number line, is we're looking for the number's distance from the origin in the complex plane. So if I want to find the absolute value of 3 plus 4i, an imaginary number, there's a couple of ways that I could think about this. One way I could think about this is to use a little bit of geometry, and I think of my friend Pythagoras. 3 plus 4i on the the complex plane, this being the real axis and the imaginary axis. 3 plus 4i would exist right here, 3 to the right and 4 up. So there's the number 3 plus 4i. Now, one way that I could figure this out is geometrically. How far is that point from the origin? Well, if you notice, I've got this nice right triangle that exists here. And I bet I could figure out the lengths of the sides of this right triangle. Well, this length is 3, and this length happens to be 4. And what I'm trying to figure out is the length of the hypotenuse. Now, we happen to know something called the Pythagorean Theorem that helps us figure that out. A squared plus b squared equals c squared, where a and b are the legs of a right triangle, and c is the hypotenuse. So to solve this equation for the length of the hypotenuse, 3 squared plus 4 squared equals I don't know what squared. Well, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. 25 is equal to something. Instead of a question mark, I'll make it C again. To solve that equation, just like we've been doing during this chapter, I take the square root of both sides. C must equal 5. I don't need the negative version of this because absolute value is a distance, and a distance is always positive. So in this case, the absolute value of this number would be 5. And you might recognize this as being a 3, 4, 5 right triangle. Anyway, you maybe could have saved yourself the trouble. Now, if geometry is not your thing, there is an algebraic formula that we could use to find the absolute value of a complex number. I'll use z instead of c. It's just a different variable, but that's okay. To find the absolute value of z, a complex number, I take the square root of a squared plus b squared. Well, guess what? Doesn't that look a lot like the Pythagorean theorem did? It's just instead of leaving it as z squared, they did the work of taking the square root for you in the formula. If I was going to use that idea here without geometry, I would take, to find z, the absolute value, I would take the square root of 3, the real part squared, plus b squared. Now, the I has nothing to do with this. We don't care about I. Don't worry about it. Just take the 4, just the number part, and square it. And once again, 3 squared is 9, 4 squared is 16. We've already got that. Add them, it's 25. Square root, it's going to be 5. Same answer, doing it either way. The next example, if I use my formula, this is going to equal the square root of a squared, which is negative 2 squared. I put it in parentheses to make sure that it ends up as a positive number. And plus b squared, well, 5 squared is going to go here. Negative 2 squared is 4. 5 squared is 25. I have 4 plus 25, square root of that. Well, that's going to equal the square root of 29, which is simplified as far as it gets. 29 is no perfect square factor, so this is my absolute value. One more example, 5 minus 3i. To find the absolute value, we take the square root of a squared plus b squared. B is negative 3. 5 squared is 25. Negative 3 squared is 9. So the square root of 25 plus 9, well, that's going to turn into the square root of 34. Once again, a 34 has no perfect square factors other than 1, so this is a simplified answer. There you have it, finding the absolute value of a complex number.